Yeah. So, hello everyone. This is AP Physics. Welcome to your own channel. So today we'll be starting with gravitation. Okay. So this is a continuous series of classes. The sessions will be complete and based on this chapter, gravitation. So let's start. Okay. So our strategy will be this. We'll be starting with a series of concepts and then important numericals. Basically, it's not important; it's most important numericals. Okay. Let's start. So there are a lot of things to be understood before starting this chapter as gravitation. We all know the story of how it all started and the beginning as, this chapter basically. So this thing, Sir Isaac Newton was sitting below the tree, apple tree, and it was, I think it was some kind of, issues were going on in the country, and then he was sitting below the tree, and then apple fall, and it like, because it's a scientist's mind, and he started thinking what's all happening, and then he concluded at the last with a lot of research. So we'll start the formulas and we'll continue towards the variables. So based on all these things, you will conclude we have two objects and they lie at opposite forces on each other. Despite all those things, okay? So suppose we have two masses, say mass m1 and mass m2, and these two masses are at r distance from each other. So Newton had observed that two bodies having the masses m1 and m2 apply the attractive forces towards each other. Okay. And those forces are given by an expression which is basically Newton's law of gravitation. Magnitude of the forces will be a vector, action reaction pair, that is Newton's third law of motion. But the magnitude will be G m1 and 2 upon r square. See, there is a description behind that a force is basically proportional to product of the masses of the two bodies, inversely proportional to square of the distance between them, and then if you want to remove that proportionality, I mean, if you want to introduce equal to sign here, if you want to make an equation, we need to introduce a constant of proportionality, which is basically G, universal gravitation cost. Okay. So we have G here. Universal gravitation constant. And what's the value of this G? I will provide you here this concepts. Okay. So all the concepts which you will find in this section will be this. You just remember that, understand that, and then apply the numericals while solving the numericals. Okay. Is not it on? Then we'll see a few problems about this law. Okay. So since now we are able to solve the numericals by using this equation, that is F is equals to capital G, universal gravitational constant, which is 6.67 10 minus 11 Newton per square on kg square, product of the masses, and distance square, inversely proportional. So we'll see our properties of this force. Let's understand first star property. Very much interesting. Let's first discuss the first 2 points, please. So the first point it says it's always attractive in nature. Yeah, I mean it's an experimental thing. You can observe that is falling and you watch, why it's happening, why an event how events like this here and there. I mean he concluded with some force which is that's core gravity. And then he applied this to universe, and then he called this as universal law of gravity. It's not just the Newton's law of gravity. I mean, Newton, yeah, of course, we pay respect to our scientists, but we say like this: it's universal Newton's law of gravitation. Why universal? It is universally applied. Okay, so we will say it doesn't. It's not like this. If you go into the water, gravitational force will change. Other forces may apply, obviously, like we say, whatever, but gravitational forces we do only remember this thing. Okay, it's I hope you understood this. And of course, we know the value of G. Again, I'm repeating it so that you may always remember the value. Although in the exams we get the values of different constants, we like to study constant, gravitational constant, other constant, but still we must remember it. It's good. These are the signs of a good student, a physicist. And you don't have to waste the time when you are going to write the exam, isn't it? Is what you're done. Okay. So now we will be solving a numerical. Okay. I want you to answer this. So basically you're having two masses. This is a small mass M and this one is the big one. Okay. And they are from center to center, from center to center of the spheres, they are kept at r distance from each other in air. Okay. Now, if we say these set of system, I mean, this system consisting of small mass and capital mass is taken from the air and is being kept into a medium having the specific gravity equals to 3. Okay. If I say, or you can write in a modified form, I'm writing here a modified form. So now your question is this, that if you're having two spheres, one is the small mass m, and other one is the capital mass m, capital M. And they are situated at a distance r from center to center. I mean, from center to center, the distance is r. So 100% there will be some attractive force, that is the gravitational force, which we know, that is F equals to G over N2 upon R square. So if that force is equals to F, you know its action direction, so it will come like this. Now, if the medium is changed with a specific gravity equals to 3, what will be new gravitational force? You have to answer in terms of this F. It can be applied to, etc. Please answer this. Take your time. So now I hope you have your answers. If anybody want to comment, please send it on the YouTube or in the Zoom session. It will appear in front of me. No worries. Okay. So see, it's a very tricky question and very easy as well. Okay. See, actually, the question is, I want to confuse you. Why? Because we already studied it. Yes, the gravitational force is basically, we will say like this. We'll say like this, that universal Newton's force of gravitation, it's this gravitation force, is basically medium independent. Is medium independent. It's independent of the medium. So whether you take it to space, moon, Jupiter, anywhere, the force will be same. That is F dash is equal to the initial Latin magnitude. This is your required answer. Okay, please note it down fast. So now I will be Studying the next topic. So, principle of superposition of universal law of gravity. What is this thing? So, understand this. Suppose in a space, so when I'm talking about the space, I will say x-axis, y-axis, and this is z-axis. Okay. So suppose we have the masses, say m1, m2, m3, m4, m5, and say m6. And okay, let's take this 6 masses. Okay. So if I talk about the m5, understand this: universal of gravitation will be due to all the masses. Okay. So m1 will also affect this with f1, say f1 5, force on. Okay, by writing this, we'll say f51, that is force on mass number 5 due to 1. So m3 will also affect it, force on mass number 5 due to 3. M4 will also affect it, force on mass number 5 due to 4. M6 will also affect it, force on mass number 5 due to 6. M2 will also affect it. So we'll say force on mass number 5 due to 2, mass number 2. So principal superposition says that net force on this M5 mass will be the vector summation or the vector sum of all the individual attracting gravitational forces due to what? Due to all the masses in the vicinity of this M5 mass. So I will say the net force will be what? So F net on M5 will be force on 5 due to 1, force on 5 due to 2, then I say 5, it means mass 5. Force on 5 due to 3, dash up to force on 5 due to 6. So this is our superposition net force equation. It's very interesting actually. This is not down, this is a generalized case. After this, we will be solving mathematical. Okay. So now we will solve a numerical based on this principle of superposition. Okay, let's start it. So the question is this: you are having a square, and on the 3 vertices of square, you are having a mass m, mass m, mass m. Let's say A vertices, B vertices, C, and D. So you are having a square and 4 vertices, that is A, B, C, and D. On A, the mass is smaller. On B, the mass is 1 kg. It's numerical mass. On C, the mass is m, again generalized. On D, the mass is small m. So the question is this, that you have to find net force. Which force? Gravitational force. Please provide your answer. Very easy question. Let me, solve this. So it's very easy. We have the three masses. This one has the force has been added on this mass. Okay. So I will be solving it now. Students, this is one of the easiest question. Okay. And very easy. So if you see on 1 kg mass, this mass will apply attractive force in this direction. On this 1 kg mass, this C1 will also apply force in this direction. On this 1 kg mass, this D mass will also apply a force in this direction. Any queries in this? I think it's very easy, attractive force towards the mass. So if you see line of joining of these two masses is this only, so it perceives us to be like a diagonal, isn't it? And for this, the line of joining is this. For this, the line of joining is this. It's finished here. Of course, there will be actual reaction force. If M is a line of force on 1 kg, 1 kg will also apply. This will also, this will also. On this will also, C and D also. Okay, let's solve this now. So let's take it and solve it vectorially. So here the force is this. So it's how much? Suppose let's assume the length is L, the length is L, the length is L. So you will say like this. Here the force will be F naught is equals to G. It is M 1 upon L square. Here the force is F naught G. This is M 1 upon L square. Okay. And if I see this force, it's a diagonal force. Square is having diagonal as 90 degrees. So diagonal must be between, that is 45 degree and the same 45 degree. Okay. So this force will be how much? Really, it's very easy. Diagonal length is, this is base perpendicular. So this is by Pythagoras, it's how much? If you are solving it by Pythagoras directly, how much it will be? It's very easy again. So we'll say L square plus L square square root. This gives you the answer as root 2L. Again, very easy. So this force will be equals to, let me multiply that one, which is equals to G. Mass is M, 1 kg. Product of the mass is distance square. Distance is how much? It is root 2L square. So net force is equals to Gm upon L square plus Gm upon L square plus Gm upon 2L square. Okay. So is this fine? Yeah, that's fine. No worries in this. Is it fine? See, if you are solving it vectorially, this is the wrong answer. This was a question for you. Okay. So let me tell you what the answer will be. Because we are not just adding the magnitudes, these forces are being added as like what in a vector manner. So we will tell some of this and this will be, some of this and this will superimpose on this, or will be in the alignment of this force. These two forces will be parallel. So directly alignment, definite squares of this will be equally aligned in something as a square force. So that is root 2a. So write it as root 2 Gm upon L square, and the sum of these two forces will be parallel to this in the alignment of this. So plus we can add to this directly. So when it puts now added directly. So you will say Gm upon 2L square. So answer comes out to be Gm upon L square root 2 plus 1 upon 2. This is your required answer. Okay, please solve it. Will not be done fast. I'm repeating it again. You can't just add the magnitudes. This plus this plus this. No, it's wrong. Because it's a vector sum. Principle of superposition says you have to vectorially add the things. So this and this will be in between of this. What's that mean? Why? Because both the vectors are of the same magnitude. So let some will be what is that will be? And perfect alignment between this. And already along the angle, this D mass is attracting this. So now all the forces, that is the vector sum of these two forces will get the vector sum of these two forces will get added with this in a magnitude manner. No worries in that. I hope you understood it. Okay, now I'm erasing this. So I think that few students are having query in on YouTube session. I feel that few students are having query on YouTube session. Can we check? Is there any info on YouTube? Yes. Okay. On YouTube session. Is there any info on YouTube? I think one will probably, isn't it? Yes. Okay, now is this. So I think that the source of actually source is source of nature. Also have salmon you also watch salmon like however it's us and Christmas so see that he was just on stop. So let's see it's all so there was just this thoughts you know the length is yeah it's fine now. I think I changed the things. Okay. So we will be continuing from the next session. Okay. Till then, if you have any comments, please give your comments in the comment box. Okay. For Zoom session, please look for the description link. Okay. Thank you.